Hello everyone and welcome to UrbanSubnet.com. Today we're going to be talking about connecting to the internet. We're going to talk about the essentials needed to connect to the internet. What is the bare essential in hardware and software that we need to connect to the internet or to a network? We're going to look at how to configure an IP address on a computer and on a network device. So we will take a look at how to configure those addresses on actual network devices. We're going to look at the subnet mask and how important it is to make sure that is configured correctly. We're going to test the ping command, and we're going to look at the traceroute command. Ping and traceroute is part of the TCP/IP protocol, and they're used to help us troubleshoot the network and to see if devices are actually reachable from one another on the network with the ping and the traceroute command. So when we think about connecting to the internet, some things are absolutely needed, and one of those things that we need is a computer, and we also need a monitor, a keyboard, and a mouse so we can interact with that computer. So we're going to need a computer hardware, of course. It's going to have to be operating properly. It's going to have a operating system installed on it. There are various operating systems out there, but you're going to need a working operating system on a working computer that has power and is turned on and ready for use. You're also going to need in that computer to have a functioning network interface card. This network adapter is what you use to connect your computer with a cable to your modem to go out to the internet. So you're going to need a working network interface card, or what we call a NIC card, in your computer. You're also going to take a cable, like we said earlier, and you're going to connect to your modem. Your modem may have been supplied by your phone company, whether you're using Verizon, Comcast, or Cox, or someone like that, but they probably have provided you with a modem already. If not, you can go down to your local electronics store and purchase a modem and also connect that. Now, on one end of this modem is going to connect to some kind of phone jack, or maybe even a coaxial cable into your house. So that will run into your house. The cable from the house will run into the modem, and then you will connect your computer to the modem also. So there'll be several cables going into this modem here. And this is what a standard RJ45 cable looks like. You connect one end to your computer and you connect the other end to the modem. And that's going to give you your basic setup of what you need to connect to the internet. So you have to have this equipment set up first before you can even think about IP addresses and getting on the internet. So a lot of times when you're troubleshooting, if you're working on this layer of the network, basically the physical layer of the network, the first thing you may ask someone, is your computer turned on? Are the cables connected? Is the modem turned on? Is the modem connected properly? Just to make sure that area of the network connection is complete and working properly before you try to figure out if they have the correct IP address or something like that. So this is our bare essentials for our network setup connection: cable, modems, network interface card, and our computer. Hello everyone, welcome to Urban Subnet. Today we're going to look at connecting computer devices to the network. So what we have here is two computers, PC1 and PC2. We're going to connect these computer devices to R1, which is, in our case, is our router. This isn't something that you might normally do at home, but this is just to give you an example of what it would look like when you're working somewhere and you have to set up computer devices. So first thing we're going to do is we're going to go back to our essential devices needed for a network connection, which we went through earlier, which was the computer, the NIC card, and the cables. So we're going to simulate connecting the cables of the computers to our modem or our router here. So we're going to go to this PC1 and we're going to connect it to R1 on a fast Ethernet 00 interface, and then we're going to go to PC2. We're going to connect it to R1 on the fast Ethernet 01 interface, and see we have these connections here. So now we can see them, and these devices are connected to each other here. So we're going to do that. Now we have to apply power to our devices just like in the regular world, the real world. So we're going to turn the devices on, so everything is turned on, and we can see that by the green light that and it signifies that they're on. So now the next thing we need to do is we need to go into each device. On the computers, you might do this through your Windows software, to go into the software operating system and set the IP address. In this particular simulation, we're going to have to go into a terminal interface on the computer. So you can here we're just going to go click here, and we're going to bring up this terminal interface where we can enter commands into the PC to get it to work for us. And then we're going to do the same thing on PC2. So we can go into PC2 and enter in the IP address information, and we're going to do the same thing on our router here. So we can actually go into the console port on the router and put in commands. So this video is IP addressing. So the first thing we're going to do is we're going to go into the configuration of the router. We're going into the interface on the router, interface FA0/0, fast Ethernet 00. We're going to put in the IP address, and we're going to use the 10.10.10 network. So 10.10.10 is our network number, 10.10.10, and this router 1, we're going to give it an IP number or IP address of 1. So the router is going to be number 1 on the 10.10.10 network, and it's going to have a subnet mask of 255.255.255.0. Now we know why we have a 24-bit subnet mask, because our network is 10.10.10, and the first 24 bits need to be the same for the networks to be for devices to be on the same network. So we got 10.10.10, and we have 255.255.255.0 as our subnet mask for a /24-bit subnet. So we press enter, and now we do a no shutdown command on our, let's put that in there correctly, no shutdown on our interface. We press enter, and that interface should come up momentarily for us, and there it is, the log messages that says the interface FA0/0 has changed the state to up. So that means the cable is good on this interface, the IP address on the interface is there, and the interface is in the up state. Now let's go to here. Now if we try to ping 10.10.10.2, our ping will not work at the moment, because first of all, we did not apply the IP address to PC1, but 2, I just wanted to show you this is what it looks like when someone is having a computer problem. You might be logged into a switch or some other device on the same network, and you try to send them a ping to reach them, and you get back these dots, these series of dots, which means it's not working, and it says success rate is 0%. So it tells you your success was 0 for that specific ping. So now let's do this here. Let's do ping again. Let's repeat ping for a crazy number of times. So we're going to repeat the ping that many times. So now the ping is going to start going. So this router is sending packets through this interface to this computer, and it's asking the computer for a reply back, which is not getting a reply back at the moment. So let's go over to the computer PC1. Let's ping 10.10.10.1, which is the router, and we're getting a timeout, which means that I'm trying to ping it, but nothing is happening, so the ping times out after a certain amount of time. So now if we put an IP address on this computer with this command, IP 10.10.10.2/24 for the subnet mask. So this says our network is 10.10.10, and I'm device number 2 on that network. And in order to reach anyone else, I have to go to a default gateway of 10.10.10.1, which is our router. So we're going to press enter. Software is checking for duplicate addresses. No duplicate addresses was found. So now PC1 has the address 10.10.10.2 with a 24-bit subnet mask, and its default gateway is 10.10.10.1. So now if we try to ping the default gateway, it is working now. So we see reply back 84 bytes has come back from 10.10.10.1. Okay, so now if we go over to our router, we see that our pings are working from the router, because we were sending pings continuously for a huge number of times, as part of our testing here. So we're going to stop this ping here. Let's stop this here from going. Alright, so we've done that. So now we set up a connection between PC1 and R1. Now we're going to set up another connection on R1 to PC2. But we're going to do that in a different network. So in this network, we're going to use the 172.16.16 network for this next connection. So we're going to go config T, and we're going to interface FA 0/1, which is that interface, and we're going to do IP address 172.16.16.1 with a subnet mask of 255.255.0.0. Let's make it a little, let's make it a little interesting. So we're going to make this it's a larger network, but it should still work. But we're going to have a 16-bit subnet mask instead of a 24-bit subnet mask. And we're going to press enter here. So that's our IP address on that interface. And we're going to type in no shutdown. We're going to open that interface up, and we should see a message here telling us that the interface is up now. So that is good. So now if we come out of here and we do the same thing we did before, we're going to ping 172.16.16.2, which is going to be PC's 2 address. That will not work for us. Okay, so now let's go over to PC2, and we know that if we ping the router, it's not going to work. So if we do show IP on this device right here, PC number 2, it shows us the IP address information. So right now there is no IP address. Everything is 0, and the default gateway is 0. There's no DNS server. It does have a MAC address, because every device has a MAC address as it leaves the factory. This address is put onto the device at the factory, and it actually has the NIC card address that we talked about in the other video, the loopback address 127.0.0.1. So let's see if we can ping ourselves. Ping 127.0.0.1 and see what that says for us. So it actually says our own NIC card is not reachable, but I do believe that is incorrect. But this is software, not actual hardware. So there is no actual hardware NIC card in this particular setup. But if you're on your own computer and you go into your command prompt and you do that, you should be able to ping your own computer. So if we go to this computer here, we're going to our command prompt, and we're going to type ping 127.0.0.1, and let's see what my computer says. Okay, so my computer says that my NIC card is working, so we can see that my NIC card is working on my computer. If I do IP config, I get back the IP configuration for my computer, and my IP address on this computer is 192.168.1.2, and it is a default gateway at 192.168.1.1. That default gateway is the modem sitting out in my living room, so that is the modem there. Now I have a wireless network here too, and I also have a VMware, which is a virtual network that I have set up on my computer also. So here is my Wi-Fi adapter, and this address for the Wi-Fi adapter is actually 192.168.1.2. I don't have a LAN cable connection on this computer, so I have a Wi-Fi connection to my modem, and I also have a virtual network adapter for virtualware computers that I have on this particular computer, which this is a whole nother subject, so we're not going to get into that. But that is how the pinging your loopback address should work for you. So we'll close that out. Now on this computer, we're going to put in the IP address of 172.16.2/16 and a default gateway of 172.16.16.1, and we're going to put that in here. Okay, so now it says it is assigned to this PC. It's calling it PC1 because to this NIC card, there's only one PC. But this is actually PC2 with 172.16.16.2 address assigned to it. So now if we go back to our router and we try to ping the computer again, and let's see what happens. We have a success rate. So you see there were 5 packets sent and there were 4 responses. This first packet is used by the computers and the router to establish who they are, and they're on the same network. So the router will send a packet out saying, who is this person, 172.16.16.2, and he will respond back with, oh, that is me. And then the router will say, well, that person is off of my fast Ethernet 0/1 interface, so he puts a entry in the table telling him that this computer is off of that interface. We might even be able to see that. Show, and this is our what we call our ARP table. So this particular table in the router will tell us which devices are off of which interfaces. So as we can see here, we have device 10.10.10.2 off of fast Ethernet 0/1. So when the router wants to reach this IP address, it knows to send the packets out of this interface. And we have 172.16.16.2 off of fast Ethernet 0/1. This is the next hop, or the device off of the interface. This is the IP address of the interface itself, which is .1. But when something wants to reach 172.16.16.2, the router sends it out of fast Ethernet 0/1. So that's how. But that first packet is used to establish this ARP table right here, or this hardware address. This is this ARP table. So that's all we need to know for this particular video about this right here. So that first packet will be a dot saying it was unsuccessful, and you'll see your success rate was 80%, 4 out of 5. But if we do the same ping again, we should get 5 by 5. So if we do the ping once again, now we have 5 by 5 pings, because 5 pings sent, 5 replies sent back, because the router already knows how to get to this address. He doesn't have to establish a table for it because it's already in the table. Okay, so that's how that works. Now, here's something that becomes a problem in networking, but there's a problem that has been solved. But this is what happens when we're on PC number 1. If we do show IP, the PC number 1 IP address is 10.10.10.2. Okay, and PC number 2 IP address, if we do show IP now, is 172.16.16.2. So we try to ping from PC2 10.10.10.2. Let's see what happens. That ping times out. For the first 2 tries until a table is established for this particular ping. So we'll see that the ping timed out, and then we've actually started to get replies after, because this particular packet has to go from here to this router and then from this router out to PC number 1, because we're going from PC2 to PC1. So that's what happened here. On this particular router, the packet came into the router says, oh, where's that IP address 10.10.2? Then it says, oh, it's from here. So now he has a source and a destination table that was filled out in the router. So now they can ping each other. So let's go to PC1 and ping 172.16.16.2, see what happens. And we're getting a reply back. So what we've done in this video is we connected 2 computers on 2 separate networks to a router, and then the router provided connectivity to the 2 computers, and then it also provided connectivity from PC1 over to PC2. And that is how that actually works. So I wanted to show you an example of that so you can see how IP addresses work. And there's one more thing. Let's try a trace route from PC1. Trace. I believe it's trace RT on this particular software. We're going to try to trace route to 172.16.16.2. Let's see if that works for us. So that's not working here. So let's try to RECROUTE 172.16.16.2. No, that doesn't seem to work on here. So if we go to our router now and we do trace route, .16.16.2, it tells us to reach that is only 1 hop away, so it's directly connected off of this interface. Because if we do a show, IP route on this particular router, we see that it has 2 connected interfaces with IP addresses on those interfaces. So fast Ethernet 01 and fast Ethernet 0/0. So we will set up some more networks where we'll have more devices on it, where we can actually simulate trace route and some of the other protocols in a clearer fashion for you, so you could actually see how they work a little more clearly. Thank you for viewing, and have a nice day.